Hello everyone and welcome to Euclid Book 1, Proposition 7. So the language from Euclid here might throw you a little bit, but the proposition is actually pretty simple. So we just look at the picture here. I'll give you the big idea here. The idea here is we got some straight line AB, and we're going to draw some point C above, in this case, either above or below, but in this case above the straight line. And then of course we have some distance A to C and some distance C to B, okay? And the whole point of the proposition is there is no other point up here, call it D for example, but in fact there exists no other point up here anywhere such that the DA distance would equal the CA distance and the DB distance would equal the CB distance. Okay, to do that you would need D to sit literally on top of C. There is no other point up here anywhere such that this distance equals this distance and this distance equals this distance. Okay, no such point exists. One more such point, of course, does exist below. If you just sort of mirrored C below, there is another point down there, but there is no point on the same side. Okay, and it works as a proof by contradiction. It sort of says, assume there is some point D, such that this distance equals this distance and this distance equals this distance, and then derives a contradiction from that claim, thereby proving that no such point exists. So we'll just proceed here. So proposition 7, given two straight lines constructed on a straight line from its extremities and meeting at a point. So that's here. So given two straight lines, AC and CB, okay, constructed on a straight line, AB, and from its extremities, A and B, and meeting at a point, point C, there cannot be constructed on the same straight line from its extremities and on the same side of it two other straight lines meeting at another point and equal to the former two respectively, namely each to that which has the same extremity with it. In other words, there actually cannot be any point D up here that has those distances the same. And then we assume for a moment that you could. So for, if possible, given two straight lines AC and CB constructed on the straight line AB meeting at the point C. So that's this line here and this line here. Let two other straight lines, AD and DB, be constructed on the same straight line AB on the same side of it, meeting at another point D and equal to the former two respectively, namely each to that which has the same extremity with it, so that CA is equal to DA, which has the same extremity A with it, and CB to DB, which has the same extremity B with it, and let CD be joined. In other words, we're assuming, again, that point D has been picked such that CA equals DA, and such that CB equals DB, and then he says, and go ahead and let CD be joined. So we've connected this line here. And then just to explain in plain English what's coming, he's going to use proposition 5, which was the proposition that if you have an isosceles triangle, the angles in the base are the same. So if you think about it here, if CA equals DA, then this triangle right here is isosceles, right? Which would mean that this angle here, hello mousy, that angle there is equal to that angle there, okay? There we go. Sorry, that this angle here would be equal to this angle here. Oh, there we go. And then he's going to say, well, also, if, sorry about that, if CB equals DB, then this right here would also be an isosceles triangle, which would mean that this angle right here would be equal to this angle right here. Okay, and then from that we get a contradiction. But that's basically how the argument goes. So then he says, then since AC is equal to AD, so since this is equal to this, okay, the angle ACD is also equal to the angle ADC by proposition 5. So since that would be an isosceles triangle, the angle ACD right here, let me try this here, right here would be equal to right here. There we go, equal to the angle ADC. So those two angles would be equal. Then he goes on to say, therefore the angle ADC is greater than the angle DCB. So he goes on to say the angle ADC, which is this angle right here, is greater than the angle DCB. That should make a whole lot of sense. So this angle right here is bigger. So he goes on to argue that this angle right here, right there, is bigger than this angle right here, right there. Okay, which would make a whole lot of sense because, right, there we go. Whoa. Because we already said that this angle right here is actually equal to this whole big thing, and since this is only a piece of this whole big thing, then this angle right here must be bigger than this angle right here, okay? And then he says, therefore the angle CDB is much greater than the angle DCB. So the angle CDB, which would be this whole angle right here, is much greater than the angle DCB, which is this angle right here. So in other words, if this angle is already bigger than this angle, then this angle, this whole thing, must be bigger still. Okay, so the argument there is that, and let me erase those just to make it super clear. The argument, the final argument here is that this angle right here, that whole thing, is much bigger than this angle right here. Okay, that's the argument there. All right, then he continues. So now he looks at the other isosceles triangle. Again, since CB is equal to DB, so since this line is equal to this line, this also is an isosceles triangle, which means the angle CDB is equal to the angle DCB, which means, in other words, the two base angles, which are already labeled here, this and this, are equal to one another. They're the same. But wait a minute, we just proved that this angle is bigger than this angle, much bigger in fact. But now, by noticing that this triangle is isosceles, we are now claiming that by proposition 5, this angle must actually be equal to this angle. Well, of course, they can't be both. This angle cannot be both bigger than this angle and equal to this angle at the same time. So that is a contradiction. So Euclid finishes, but it was also proved much greater than it, which is impossible. Therefore, it's tetra QED. And so we have proven that there is no other point up here that can be constructed, or that can be marked, such that this distance equals this distance, and this distance equals this distance, except for a point sitting literally right on top of C. There we go.